Okay, guys, chapter 10, lesson 5, laws of algorithms. So you remember that when we have something like this, we're trying to figure out what's the exponent that goes with this base to give us this number. So another way of saying this is 2 to the something power equals 8. The answer, of course, would be 3. So we translate this into this to give us that the answer missing is 3. Okay, now this lesson gives us 3 different laws to help us solve problems and simplify problems using logarithms. So here's the first one. Whenever you have a log with a given base of 2 things multiplied together, you can find it by taking the log of the same base of each number and adding them together. So the log of a product is the sum of the log of each piece individually. The second law, whenever you have a log with a given base and one number divided by another number, it's equal to the log of the first number minus the log of the second number. Okay, so the third law, when you have the log with a given base of one number raised to another power, it's the same as that number times the log of the number by itself. Okay, these 3 laws are going to be put into practice over and over again in this lesson. So you will need to keep these in front of your face so we can do it. The proofs are given for this one and this one in the lesson. I'm not going to go over them here. And then the proof for this one is assigned as a homework problem. So that means you could figure it out yourself after you've done this one. So let's go ahead and start working some examples to see how these things work. Now, log base 6 of m squared times n cubed. Now, let's look at our laws and see if we can figure out how to rewrite this in terms of log base 6 of m squared, log base 6 of m and log base 6 of n. So how can we rewrite this in terms of this? So we're going to apply law number 1 and law number 3. Okay, so it goes like this. When you have a product, it's the added. So log base 6 of m squared plus log base 6 of n cubed. But we got to get rid of these products, so we're going to use law number 3. When you have a power, I said products, power. When you have a power, it just multiplies. So we're going to do 2 times the log base 6 of m plus 3 times the log base 6 of n. And that's the answer that we're looking for. We expressed this in simpler terms of log of m and n. Let's do another one. This time it says take log base 2 of the square root of m over n to the 5th power in terms of log base 2 of m and log base 2 of n. So we want to simplify this into terms of just this and this. Okay, now look at our laws. We have the multiplying, the dividing, and the power one. Now, when we're looking at this example, we can see that some division is happening, m divided by n, and square rooting and exponent with the 5th. So what I'm going to do is I'm going to rewrite this thing, getting rid of the radical and making it into an exponent. So let's look at it like this. Log base 2 of m over n to the 5th to the 1/2 power. Then, if you remember your rules of exponents, I can rewrite this again and have it be like this. Log base 2 m to the 1/2 over m to the 5 times 1/2. Okay, now, do you see the division and the powers? So it's going to be just like the one we just did, and we're going to the division changes to a minus problem. So let's change it to a minus. I'm going to do this guy up here. Okay, so log base 2 of m to the 1/2 minus log base 2 of m to the 5 times 1/2. I'm just going to go ahead and call it 5/2. Okay, so we changed the division to a subtraction. Now we're going to rewrite it with the exponent according to law number 3. The exponent becomes a factor. So I'm going to take that half and bring it in front of the log. And I'll do the same thing with the other one. And that's the answer. We took the original log base 2 of the square root of m over 5, m to the 5th power, and we re-expressed it more simply in terms of log of m and log of n. Okay, let's do a couple more, and you guys will be ready to go. Okay, now in this time, we're going to work it in reverse. So I'm going to start us off with some logs. Log base 10 of p plus 3 times log base 10 of q. And then the work says express it as a single logarithm. Now the bases are the same, so we're okay. Notice that we're adding. Now the original law says that if you have them added, let's work it backwards, and this time make it to multiplication. So it's going to be the log base 10 of p times q, because we added. And then the q, if you remember the third law, notice we have 3 times that log, so it becomes an exponent. So the log base 10 of p times q to the 3rd. That's what they're looking for right there. Let's do another one. This time we have 4 log base 10 of p minus 2 log base 10 of q. Okay, we're going to use law number 2. The minus is going to turn into a division, and then the numbers multiplied by the log will turn to an exponent. So I'm going to have a single log base 10 with p to the 4th power divided by q to the 2nd power. Done. Okay, let's do one more set. This one has 4 in it, but we're going to actually use this information to solve some logarithmic equations, or to simplify it, start with. Okay, log base 10 of 2 is equal to 0.30. So that's just a stated fact. Okay, next one. Log base 10 of 3 is 0.48. So if I ask you to simplify this, you'll say 0.3. Ask you to say this, you'll say 0.48. Now we're going to use this information and figure some things out, like what is log base 10 of 18? Well, remember, if we can express 18 as a product of 2's and 3's, then we can simply add these together. Watch what I mean. Log base 10 of 2 times 3 times 3. These are the same thing, right? Because 2 times 3 is 6, times 3 is 18. Now, what did we learn about the log of products? It's the same thing as this. We are transforming multiplication into addition. So log of 10 of 2, log of 3, and log of 3. Well, we actually have these numbers here, so the log of base 10 of 2 plus the log base 10 of 3 plus another log base 10 of 3. And so there we go. The answer, when you add it all up, is 1.26. So the log 10, base 10 of 18, is 1.26. And we used these two things to figure it out. Let's do that again. We're going to keep this alive. We got to use that, and we're going to do this problem now. Log base 10 of 20 divided by 3. Now, in this first example, we changed 18 into a series of factors, of products. Now, in this one, we've got to do the same thing, but then we're going to use the division to help us out. So log base 10 of 2 times 10 divided by 3. Now 10's okay because we have a base of 10. I'll show you what happens there in a second. So log base 10 of 2 plus log base 10 of 10 minus, because it's division, log base 10 of 3. Now, here's our little chart. The log base 10 of 2 is 0.30. Now, anytime you have 10 and a 10 like this, it's going to be 10 to what power gives you 10? 10 to the first power. And then this one was 0.48. So by the time we work these numbers out, 1.3 minus 0.48 is 0.82. Got it. Okay, let's do another one. Where are we at? Okay, there we go. Sorry. Next, we have the log base 10 of 5. Now how are we going to do this? Well, 5 is actually 10 divided by 2. As long as we can take this number and express it in terms of 10 or 2 or 3, we can solve it. So we look at 5 and realize, okay, we can get that with 10 divided by 2. And so then it just becomes a matter of 10 minus log base 10 of 2. Log base 10, that's 1 minus 0.3. The answer is 0.70. They gave us our number to 2 decimals, so we need to keep everything in terms of those 2 decimals, 2 decimal places. Okay, one more. Okay, log base 10 of 1 over the cubed root of 2. Okay, let's rewrite this without a radical, make it an exponent. 2 to the negative 1/3 power. Now, what do we do with the exponent? Remember, we multiply it off to the side. So we have negative 1/3 log base 10 of 2. Well, the log base 10 of 2 is 0.30. So I'm going to bring it down here. So we've got negative 1/3 times 0.30. And the answer is negative 0.10. Okay, now, how can we use this to solve an equation? Last example. I've said last example like 3 times, but we can. Suppose you've got log, but this really is the last one, log base 3 of x plus log base 3 of x minus 6 equals 3. Can we find x? Yes, we can. Here's how. We know that the stuff here added together is going to be a single log as a multiplication. Okay? Then we know that 3 to this power is equal to this, because that's what a log is, right? 3 to the 3rd power is this. So let's do that. 3 to the 3rd power is, and I'm going to go ahead and multiply it through, is that. Okay, 3 times 3 times 3 is 27. Okay, and then I'm going to subtract 27, and what's going to happen is we've got a quadratic equation, which I can now factor. And this one they gave us an easy one. We don't have to use the formula. 9 and 3. So this will be minus, and that'll be plus. So x equals negative 3, or x equals 9. Now, a log can never have a negative answer. Only positive are legitimate. So x equals 9. We figured it out. Yes. All right. Let me know if you guys have any questions and you work some of these problems. I'm here if you need me.